So you may have walked into your chemistry class and seen a giant poster with a table on it, which will look something like this. Well, you might be intimidated by all the numbers and letters, you don't know what they mean. Well, I'm here to help you figure out and read this table so that you won't be intimidated anymore. This is the periodic table of elements. And first of all, I'm on this website, www.ptable.com, and this shows what is the dynamic periodic table created by Michael Dea. I'm sorry if I mispronounced your name. And this periodic table is really nice because, as you can see, there's many colors. Each color represents a certain group in the table, and you can mouse over the groups and it will highlight what group you're mousing over, which is really nice. And also, if you don't know anything about the element, for example oxygen, you can click on it and it will open up the Wikipedia page to the element. Also, if you want to look at properties of elements, orbitals, or electron configurations, you can see the different shapes of orbitals and their orientations here, or isotopes or compounds that each element might partake in, or you may see in. Well, that's all the other tabs up here. Alright, so let's begin how to learn how to read the periodic table. Alright, here I've written hydrogen, just shown, same as shown on the website. So hydrogen, it has a bunch of these numbers. We know it's hydrogen because it's written right here. So first of all, the most obvious thing that we look at is H. H stands for hydrogen, and this is called the elemental symbol. Alright, so this number up here, this is called the atomic number. And if you don't know what the atomic number is, it basically just tells us the number of protons that an atom has, or an element. And down here is the atomic mass, or the mass number. And this number tells us the mass of the atom of an element. Usually it is just the number of protons and neutrons combined, because their masses are 1 if you round it up. And so what we can see here is that its atomic mass is 1, the atomic number is 1, so we have 1 proton, and since the atomic mass is just barely over 1, we can assume there's only 1 proton and no neutron in the hydrogen element. Now before we begin with reading the periodic table, I have the definition of a valence electron here. The valence electrons are the 8 electrons on the highest energy level of an atom. And they're very important because they're the ones that are involved in chemical reactions, and they're the electrons that move around when you see an element become an ion. And so let's begin with the group or column that has 8 valence electrons. So a common theme in chemistry and about elements is that 8 valence electrons make an element happy. And so this group of elements are called the noble gases. They all have 8 valence electrons except for helium, which has 2 valence electrons. And so all these elements, they're already very happy with the 8 valence electrons in their highest energy level. So this means that they're not very reactive. They do not want to lose this valence electron, or they do not want to gain any more valence electron, because that means they'll be going to the next energy level. And so an atom will really want 8 valence electrons to be happy. But a really good thing to know, if you're very confused on if an element is happy or not, just make sure they have the same amount of valence electrons as one of the noble gases. Alright, so let's continue on to column 1. So column 1, it has a group called the alkali metals. And these are metals which have one valence electron only. So how do they become happy if they only have one? Well, that means they have to gain 7 more valence electrons. Actually, that's really hard to do, to gain 7 more valence electrons. So what they like to do is they like to lose a valence electron and they will become a positive ion. In column 2, we have the alkaline earth metals. Don't get confused with alkali metals and alkaline earth metals. These guys are in group 2, or in column 2, and they have 2 valence electrons. And just like the alkali metals, they like to lose their valence electrons to become very happy elements. Now in the middle here, this giant group of elements from column 3 to column 12, they are the transition metals. And they vary on the amount of valence electrons that they have. As you see these two groups on the bottom, these two rows of elements, we don't really need to pay too much attention to them because they're human synthesized elements. These next two groups are the post-transition metals, you can see here in the kind of light blue color, and the metalloids. So the post-transition metals are just over here, and they're also metals. And the metalloids are located right here. And they're in our own group because these elements have some characteristics of metals and some characteristics of nonmetals. This group of elements highlighted in the green, they are called the nonmetals. And also the noble gases are nonmetals, but we call them noble gases. And if you can notice on the top left is hydrogen. Hydrogen is an element that's part of the nonmetal group. One thing to note about the nonmetals, this group in the column 17, fluorine, chlorine, bromine, and iodine, they are all called halogens. That's the special name for them. And they all have 7 valence electrons, and that means they only need one more electron to be really happy. So these halogens are very, very reactive. They really want electrons. Not all elements have elemental symbols that are easy to figure out, like hydrogen and oxygen, which are H and O. They're just the first letter of the element name. These are some elements in the periodic table that you probably should know the elemental symbols for, because they're pretty common to see. Copper, iron, silver, gold, mercury, tin, lead, antimony, sodium, and potassium. All elements in the periodic table can be classified into 3 categories: metals, nonmetals, and metalloids. So let's start off with metals. What are some characteristics of metals? Well, most of them are on the left side of the periodic table, and that actually means that most of them have somewhat little valence electrons. So probably 3, 2, or 1 valence electrons. And this means that they will form positive ions or cations when they undergo a chemical reaction, because they really want to lose those electrons. That's the easier route to go for metals to become happy. And another trait of them is that they are good conductors of heat and electricity. Let's talk about nonmetals now. So what are some characteristics of nonmetals? Well, first of all, they have more valence electrons than metals. That means they'll form negative ions, or or anions. And also, they're not very good conductors of heat and electricity. And so, let's go on to metalloids now. You can also call them semimetals or semiconductors. So, metalloids, they're also called semimetals because they have some characteristics of metals and some characteristics of nonmetals. So this means that they're decent conductors. They're not as good as metals. Decent conductors of heat and electricity. Now we know how to read a periodic table. Here I have 4 questions that can help us practice reading the periodic table. And so, let's start off with number 1. What is the elemental symbol for gold? So gold, let's look for it in the periodic table. It's in the 11th column and you go 3 down. So the elemental symbol is Au. Alright, number 2. I've written bromine down. So I've written bromine down, but it's not like the way it's written on the website. We have 2 numbers in different places. So what are these numbers? Well, this number right here is the atomic number. It's the atomic number, I think. So let's look it up. Bromine is in the 17th column, and yep, it is the atomic number. So what does the atomic number tell us? It tells us the number of protons. So this means there are 35 protons in bromine. Now this one up here, this number is the mass number now. And how do we find out the number of neutrons using the mass number? Well, we just subtract the mass number with the number of protons, because the atomic mass unit of protons and neutrons is 1, so they weigh about the same. So there are 45 neutrons in bromine. Alright, number 3. Put in order from least conductive to most. Metal, metalloid, and non-metal. So which one of these are the least conductive? Non-metals are. And what is the second least conductive? Metalloids. They can also be called semi-metals or semiconductors. And that makes metals the most conductive of all of them. Alright, so number 4. What group is CAN? So let's look for Ca. Where is it? It's in column 2. Column 2, and you go 3 rows down in row 4. And Ca is in the second column. That means, what's the name of the group in the second column? They're the alkaline earth metals. Alright, now we know how to read the periodic table.